118 elements are known to the scientific world. However, around year 1800 only, about 30 elements were known. More number of elements were discovered in the course of time. More and more information about the properties of these elements was gathered. To ease the study of such a large number of elements, scientists started studying in the pattern refining. In the vast information about them, you know that in the initial classification, elements were classified into the groups of metals and non-metals. Later on, another class of elements called metalloids was noticed. Later on, another class of elements called metalloids was noticed. As the knowledge about elements on their properties went on increasing, different scientists started trying out different methods of classification. The Bariniers tried. In the year 1817, a German scientist, de Barinier, suggested that the properties of elements are related to their atomic masses. He made groups of 3 elements each, having similar chemical properties, and called them triads. He arranged the 3 elements in a triad in an increasing order of atomic mass and showed that the atomic mass of the middle element was approximately equal to the mean of the atomic masses of the other 2 elements. However, all the known elements could not be classified into Barnier's serial number, triad, element, -1, actual atomic mass in bracket A, element, -2, mean is equals to A plus C upon 2, actual atomic mass, element, -3, actual atomic mass in bracket C. Point 1, LiNaK, lithium in bracket Li 6.9, sodium 6.9 plus 39.1 upon 2 is equals to 23.0 in bracket Na, 23.0, potassium in bracket K 39.1. Point number 2, CaSrBa, calcium in bracket Ca 40.1, strontium 40.1 plus 137.3 upon 2 is equals to 88.7 in bracket Sr, 87.6, barium in bracket Ba 137.3, ClBrI, chlorine in bracket Cl 35.5, bromine 35.5 into 126.9 upon 2 is equals to 81.2 in bracket Br 79.9, iodine in bracket I 126.9. Newland's law of octaves. The English scientist John Newland correlated the atomic masses of elements to their properties in a different way. In the year 1866, Newland arranged the elements known at the time in an increasing order of their atomic masses. Started with the lightest element, hydrogen, and ended up with thorium. He found that every 8th element had properties similar to those of the first. For example, sodium is the 8th element from lithium and both have similar properties. Also, magnesium shows similarity to beryllium and chlorine shows similarity with fluorine. Newland compared this similarity with the octaves in music. He called the similarity observed in the 8th and the first element musical note, Do in bracket SA, Re in bracket Re, Mi in bracket Ga, Fa in bracket Ma, Sol in bracket Pa, La in bracket Dha, Ti in bracket Ni. Elements H, Li, Be, B, T, N, O, F, Na, Mg, Al, Si, P, S, Cl, K, Ca, Cr, Ti, Mn, Fe, Co and Ni, Cu, Zn, Y, In, As, Se, Pr, Rb, Sr, Ce, and La, Zr. Do you know, in the Indian music system there are 7 main notes, namely sa, re, ga, ma, pa, dha, ni, and their collection is called saptak. The frequency of the note goes on increasing from sa to ni. Frequency of the notes goes on increasing from sa to ni. Then comes the sa of the upper saptak at double the frequency of the original sa. It means that notes repeat other completion of one saptak. The 7 notes in the Western music are do, re, mi, fa, so, la, ti. The note do, having double the original frequency, comes again at the 8th place. This is the octave of Western notes. Music is created by the variety in the use of these notes. Mendeleev's periodic table. The Russian scientist Dmitry Mendeleev developed the periodic table of elements during the period 1869 to 1872 AD. Mendeleev's periodic table is the most important step in the classification of elements. Mendeleev considered the fundamental property of elements, namely a standard and arranged 63 elements known at the time in an increasing order of their atomic masses. Then he transformed this into the periodic table of elements in accordance with the physical and chemical properties of this element. Mendeleev organized the periodic table on the basis of chemical and physical properties of the elements. These were the molecular formulae of hydrides and oxides of the elements, melting points, boiling points, and densities of the elements and their hydrides and oxides. Mendeleev found that the elements with similar physical and chemical properties repeat after a definite interval. On the basis of this finding, Mendeleev stated that the following periodic law properties of elements are periodic function of their atomic masses. The vertical columns in the Mendeleev's periodic table are called groups, while the horizontal rows are called periods. Introduction to scientist. Dmitry Mendeleev, 1834 to 1907, was a professor in the St. Petersburg University. He made separate cards for every known element showing its atomic mass. He arranged the cards in accordance with the atomic masses and properties of the elements, which resulted in the invention of the periodic table of elements. Merits of Mendeleev's periodic table. Science is progressive. There is a freedom in science to revise the old inference by using more advanced means and methods of doing experiments. These characteristics of science are clearly seen in the Mendeleev's periodic table. While applying the law that the properties of elements are a periodic function of their atomic masses to all the known elements, Mendeleev arranged the elements with the thought that the information available till then was not final, but it could change. As a result of this, Mendeleev's periodic table demonstrates the following merits. The point 1. Atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, the previously determined atomic mass of beryllium 14.09 was changed to the correct value of 9.4 and beryllium was placed before boron. Point number 2. Mendeleev kept vacant place in the periodic table for elements not discovered till then. 3 of these unknown elements were given the names Eka, boron, Eka, aluminium, and Eka, silicon from the known neighbors, and their atomic masses were indicated as 44, 68, and 72 respectively. Not only this, but their properties were also predicted later. On these elements were discovered and named as scandium, Sc, gallium, Ga, and germanium, Ge, respectively. The properties of these elements matched well with those predicted by Mendeleev's table. Due to this success, all were convinced about the importance of Mendeleev's periodic table, and this method of classification of elements was accepted immediately. Point number 3. There was no place reserved for noble gases in Mendeleev's original periodic table. However, when noble gases such as helium, neon, and argon were discovered towards the end of the 19th century, Mendeleev created the zero group without disturbing the original periodic table in which the noble gases were fitted very well. Demerits of Mendeleev's periodic table. Point number 1. The whole number atomic mass of the elements cobalt, Co and nickel Ni is the same. Therefore, there was an ambiguity regarding their sequence in Mendeleev's periodic table. Isotopes were discovered long time after Mendeleev put forth the periodic table, as isotopes have the same chemical properties but different atomic masses. A challenge was passed in placing them in Mendeleev's periodic table. Point number 3. When elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible. Therefore, to predict how many mass does not appear to be uniform, it was not possible. Therefore, to predict how many elements could be discovered between two heavy elements. Point number 4. Position of hydrogen. Hydrogen shows similarity with halogens, group 6. For example, the molecular formula of hydrogen is H2, while the molecular formula of fluorine and chlorine are F2 and Cl2, respectively. In the same way, there is a similarity in the chemical properties of hydrogen and alkyl. There is a similarity in the chemical properties of hydrogen and metals, group 1. There is a similarity in the molecular formula of the compounds of hydrogen, alkali metals, Na, K, etc. Formed with chlorine and oxygen. On considering the above properties, it cannot be decided whether the correct position of hydrogen is in the group of alkali metals, group 1, or in the group of halogens, group 2. Modern periodic law. The scientific world did not know anything about the interior of the atom when Mendeleev put forth the periodic table. After the discovery of electrons, scientists started exploring the relation between the electron numbers of an atom and the atomic number. The atomic number in Mendeleev's periodic table only indicated the serial number of the element. In 1913 AD, the English scientist Henry Moseley demonstrated with the help of the experiments done using X-ray tube that the atomic number Z of an element corresponds to the positive charge on the nucleus or the number of the protons in the nucleus of the atom of that element. That atomic number is a more fundamental property of an element than its atomic mass. Accordingly, the statement of the modern periodic law was stated as follows. Properties of element are a periodic function of their atomic number. Modern periodic table, long form of the periodic table. The classification of elements resulting from an arrangement of the elements in an increasing order of their atomic numbers is the modern periodic table. The properties of elements can be predicted more accurately with the help of the modern periodic table formed on the basis of atomic numbers. The modern periodic table is called the long form of the periodic table. In the modern periodic table, the elements are arranged in accordance with their atomic numbers. As a result, most of the drawbacks of Mendeleev's periodic table appear to be removed. However, the ambiguity about the position of hydrogen is not removed even in the modern periodic. We have seen in the previous standard that the electronic configuration of an atom, the way in which the electrons are distributed in the shells around the nucleus, and the total number of electrons in an atom is same as the atomic number. The relation between the atomic number of an element and its electronic configuration is clearly seen in the modern periodic table. Structure of the modern periodic table. The modern periodic table contains 7 horizontal rows called the periods 1 to 7. Similarly, the 18 vertical columns in this table are the groups 1 to 18. The arrangement of the periods and groups results into formation of boxes. Atomic numbers are serially indicated in the upper part of these boxes. Each box corresponds to the place for one element. Apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table. These are called Lanthanide series and Actinide series respectively. There are 118 boxes in the periodic table including the 2 series. It means that there are 118 places for elements in the modern periodic table. Very recently, formation of a few elements was established experimentally, and thereby the modern periodic table is now completely filled. All the 118 elements are now discovered. The entire periodic table is divided into 4 blocks, viz. S block, P block, D block, and F block. The S block contains the group 1 and 2. The groups 13 to 18 constitute the P block. The groups 3 to 12 constitute the D block, while the Lanthanide and Actinide series at the bottom form the F block. The p block elements are called transition elements. A zigzag line can be drawn in the p block of the periodic table. The three traditional types of the elements can be clearly shown in the modern periodic table. With the help of this zigzag line, the metalloid elements lie along all the metals lie on the left side of the zigzag line, all the non-metals lie on the right side. Modern periodic table and electronic configuration of elements. Within a period, the neighboring elements differ slightly in their properties, while distant elements differ widely in their properties. Elements in the same group show similarity and graduation in their properties. These characteristics of the groups and periods in the modern periodic table are because of the electronic configuration of the elements. It is the electronic configuration of an element which decides the group and the period in which it is to be placed. Characteristics of groups and periods. The characteristics of the groups and periods in the periodic table are understood by comparison of the properties of the elements. Various properties of all the elements in a group show similarity and gradation. However, the properties of elements change slowly while going from one end to the other, for example, from left to right in a particular period. You will find that the number of valence electrons in all these elements from the group 1, that is, the family of alkali metals, is the same. Similarly, if you look at the elements from any other group, you will find the number of their valence electrons to be the same. For example, the elements beryllium Be, magnesium Mg and calcium Ca belong to the group 2, that is, the family of alkaline earth metals. There are 2 electrons in their outermost shell. Similarly, there are 7 electrons in the outermost shell of the elements such as chlorine F and chlorine Cl from the group 17. That is, the family of halogens. While going from top to bottom within any group, 1 electron shell gets added at a time. From this, we can say that the electronic configuration of the outermost shell is characteristic of a particular group. However, as we go down the group, the number of shells goes on increasing. Do you know uranium has atomic number 92? All the elements beyond uranium, in bracket with atomic numbers 93 to 118 bracket close, are man-made. All these elements are radioactive and unstable and have a very short life. In the modern periodic table, point 1, elements are arranged in an increasing order of their atomic numbers. Point 2, vertical columns are called groups. There are 18 groups. The chemical properties of the elements in the same group show similarity and gradation. Point 3, horizontal rows are called periods. In all 7 periods, the properties of elements change slowly from one end to the other. Periods and electronic configuration. You will find that the number of valence electrons is different in these elements. However, the number of shells is the same. You will also find that while going from left to right within the period, the atomic number increases by 1 at a time and the number of valence electrons also increases by 1 at a time. We can say that the elements with the same number of shells occupied by electrons belong to the same period. The elements in the second period, namely Li, Be, B, C, N, O, F and Ne have electrons in the same 2 shells, and Ne have electrons in the 2 shells. K and L. The elements in the third period, namely Na, Mg, Al, Si, P, S, Cl and Ar have electrons in the 3 shells. K, L and M. Write down the electronic configuration of these elements and confirm in the modern periodic table electrons are filled in the same shell while going along a period from left to right, and at the beginning of the next period a new electron shell starts filling up. The number of elements in the first 3 periods is determined by the electron capacity of the shells and the law of electron octet. As per the electron holding capacity of shells 2, elements are present in the first period and 8 elements in the second period. The third period also contains only 8 elements due to the law of electron octet. There are few more factors which control the filling of electrons in the subsequent periods, which will be considered in the next standards. The chemical reactivity of an element is determined by the number of valence electrons in it and the shell number of the valence shell. The information on this point is obtained from the position of the element in the periodic table. That is, the modern periodic table has proved useful for study of elements. Periodic trends in the modern periodic table. When the properties of elements in a period or a group of the modern periodic table are compared, certain regularity is observed in their variation. It is called the periodic trends in the modern periodic table. In this standard, we are going to consider the periodic trends in only three properties of elements, namely valency, atomic size, and metallic non-metallic character. Valency. You have learned in the previous standard that the valency of an element is determined by the number of electrons present in the outermost shell of its atoms, that is, the valence electron. Atomic size. You have seen in the previous standards that size upon volume is the fundamental property of matter. The size of an atom is indicated by its radius. Atomic radius is the distance between the nucleus of the atom and its outermost shell. Atomic radius is expressed in the unit picometer pm, which is smaller than nanometer. In bracket 1 pm is equals to 10 raised to minus 12 m, bracket closed. Some elements and their atomic radii are given here. Elements O, B, C, N, B, E, L, I. Atomic radius pm 66, 88, 77, 74, 111, 150. You will find that atomic radius goes on decreasing while going from left to right within a period. The reason behind this is as follows. While going from left to right within a period, the atomic number increases one by one, meaning the positive charge on the nucleus increases by 1 unit at a time. However, the additional electron gets added to the same outermost shell. Due to the increased nuclear charge, the electrons are pulled towards the nucleus to a greater extent, and thereby the size of the atom decreases. Some elements and their atomic radii are given here. Element K, Na, Rb, Cs, Li. Atomic radius pm 231, 186, 244, 262, 152. Metallic, non-metallic character. It is seen that the metallic elements like sodium, magnesium are towards the left. The non-metallic elements such as sulfur, chlorine are towards the right. The metalloid element silicon lies in between these two types. A similar pattern is also observed in the other period. It is seen that the zigzag line separates the metals from non-metals in the periodic table. Elements appear to have arranged in such a way that metals are on left side or this line, non-metals on the right side, and metalloids are along the border of this line. How did this happen? Let us compare the characteristics chemical properties of metals and non-metals. It is seen from the chemical formula of simple ionic compound that the cation in them is formed from a metal while the anion from a non-metal. From this, it is understood that the metal atoms have a tendency to form a cation by losing its valence electron. This property is called electropositivity of an element. On the other hand, an atom of a non-metal has a tendency to form an anion by accepting electrons from outside into its valence shell. We have already seen that ions have a stable electronic configuration of a noble gas. How is the ability to lose or accept electrons in the valence shell determined? All the electrons in any atom are held by the attractive force exerted on them by the positively charged nucleus. Electrons in the inner shells lie in between the valence shell and the nucleus. Because of their presence, the effective nuclear charge exerting an attractive force on the valence electrons is somewhat less than the actual nuclear charge. Thus, the number of valence electrons in metals is small, 1 to 3. Also, the effective nuclear charge exerting attractive force on the valence electrons is small. As a combined effect of these two factors, metals have a tendency to lose the valence electrons to form cations having a stable noble gas configuration. This tendency of an element called electropositivity is the metallic character of the element. The periodic trend in the metallic character of elements is clearly understood from their position is the modern periodic table. Let us first consider the metallic character of elements belonging to the same group. While going down a group, a new shell gets added, resulting in an increase in the distance between the nucleus and the valence electrons. This results in lowering the effective nuclear charge and thereby lowering the attractive force on the valence electrons. As a result of this, the tendency of the atom to lose electrons increases. Also, the penultimate shell becomes the outermost shell on losing valence electrons. The penultimate shell is a complete octet. Therefore, the resolution has a spatial stability. Due to this, the tendency of the atom to lose electrons increases further. The metallic character of an atom is its tendency to lose electrons. Therefore, the following trend is observed. The metallic character of elements increases while going down the group. While going from left to right within a period, the outermost shell remains the same. However, the positive charge on the nucleus goes on increasing while the atomic radius goes on decreasing, and thus the effective nuclear charge goes on increasing. As a result of this, the tendency of atom to lose valence electrons decreases within a period from left to right. The two factors, namely the increasing nuclear charge and decreasing atomic radius as we go from left to right within a period, are responsible for increasing the effective nuclear charge. Therefore, the valence electrons are held with greater and greater attractive force. This is called the electronegativity of an atom. Due to increasing electronegativity from left to right within a period, the ability of an atom to become anion by accepting outside electrons goes on increasing. The tendency of an element to form anion or the electronegativity is the non-metallic character of an element. While going downwards in any group, the electropositivity of elements goes on increasing while their electronegativity. Point number 2. While going from left to right in any period, the electronegativity of elements goes on increasing while their electropositivity goes on decreasing. Point number 3. Larger the electropositivity or the electronegativity of the element, higher the reactivity. Gradation in halogen family. The group 17 contains the members of the halogen family. All of them have the general formula X2. A gradation is observed in the physical state down the group. Thus, fluorine F2 and chlorine Cl2 are gases. Bromine Br2 is a liquid while iodine I2 is a solid. Do you know M plus 2H2O goes to M OH2 plus H2? Chemical equation indicating the reaction of alkaline earth metals is given above. While going down the second group, as Be goes to Mg goes to Ca goes to Sr goes to Ba, the gradation in this chemical property of the alkaline earth metals is C. While going down the second group, the reactivity of the alkaline earth metals goes on increasing, and thereby the ease which the reaction takes place also goes on increasing. Thus, beryllium Be does not react with water. Magnesium Mg reacts with steam, while calcium Ca, strontium Sr and barium Ba react with water at room temperature with increasing rates.